Hi, in this video we solve question number 15 of IIT JAM 2021 mathematics paper. Here's the question. F is a bijection between natural numbers and we have to find the number of bijective maps such that the summation fn divided by n square n from 1 to infinity is finite. And to solve this question, here are some facts that are going to be useful that we recall. It is known that the series 1 by n square, n from 1 to infinity, is finite, but if you consider the series 1 by n, n running from 1 to infinity, then this series is equal to infinity. That being said, if we consider this bijection, the trivial one fn equal to n, then what do we get? If we consider this series n from 1 to infinity, fn divided by n square, and n cancels and we get 1 by n, and this says that this series is equal to infinity. By the way, this example doesn't really help us because we are only interested in the number of bijections for which this sum is finite. Now to solve this question, we are going to build some intuition based on some particular and easy examples. Let us consider sum of two terms of the following form: 1 by 1 square plus 2 by 2 square. In this sum, I want you to focus on the fact that the smaller numerator is with the smaller denominator. We will call such arrangement as numerators preserving their natural ordering. Now what happens if we just switch the positions of these numerators? What we get is this: 2 by 1 square plus 1 by 2 square. Again, this is an arrangement where the numerators are not preserving their natural ordering. Let's calculate the left hand side. Left hand side is 1 plus half, which is 1.5. The right hand side is 2 plus 1 by 4, which is 2.25, which means that the right hand side is greater. In other words, the sum is less when the numerators preserve their natural ordering, and if you take them out of order, the sum increases. Let's keep that in mind and look at another example. In this case, we consider 5 by 2 square plus 7 by 3 square. Again, in this example, we can see that the numerators on their natural position, meaning the smaller numerator 5 is with the smaller denominator 2 square. Right, let's see what happens again if we switch the numerator position from natural to unnatural. We get this sum: 7 by 2 square plus 5 by 3 square. Now let's calculate the left hand side. Let's do the cross multiplication. We have 5 times 9 plus 4 times 7 divided by 2 square, 3 square, and this gives you 5 9s are 45 plus 4 7s are 28 divided by 2 square, 3 square. Add 45 and 28, we get 73 divided by 2 square, 3 square. Now let's compute the right hand side. Do the cross multiplication. 7 times 9 plus 5 times 4 divided by 2 square, 3 square. This is equal to 7 9s are 63 plus 5 4s are 20 divided by 2 square, 3 square. Now this is equal to 83 by 2 square, 3 square. Now 83 is greater than 73. So we have got ourselves right hand side greater than left hand side. So what does this tell us? Again, if we take sum where the numerators are knocked out of their natural position, we increase the sum. If the numerators are on their natural position, the sum is less. That leads us to the following guess. If we had to consider this sum fn divided by n square, obviously the numerators will be knocked out of their natural position, so the sum will be greater than or equal to the sum when all the numerators are in their natural position. And we know that this series is nothing but the series 1 over n, which is known to diverge to infinity. Now let's try to prove our guess. To do that, we will first establish our intuition mathematically. We first claim that if we take alpha less than beta, then the following sum where the numerators are on their natural position meaning alpha divided by n square plus beta divided by n plus 1 square, is actually less than when you form the sum by switching the positions of the numerators. Proving this is actually quite easy. Why? Let's consider the difference of the right hand side with the left hand side. Let's simplify this. Take the similar terms together, you get 1 by n square beta minus alpha, plus you consider the remaining term, you have alpha minus beta times 1 by n plus 1 square. Now if you consider beta minus alpha common from both the terms, you get 1 by n square. 1 by n square minus 1 by n plus 1 square. Now this is a product of positive numbers, so this is positive. So this proves that the right hand side is actually greater than the left hand side. Thus, in the given problem, suppose fn is greater than fn plus 1. Then let's see what happens. Consider the following sum, and in this sum we can observe that the numerators are not on their natural position. From our intuition, what we just proved earlier, it means that if you bring the numerators on their natural position, you actually decrease the series. Now this is very interesting because in the original series you can always compare two terms and compare the numerators. If they are not in their natural position, you can flip them and you decrease the series. And because f is a bijection, you can find 1 in one of the numerators, then you apply the flipping until 1 comes to its natural position. Again you find 2 in one of the numerators, apply the flipping until 2 comes to its natural position. Do this till say capital N. And by doing so, you are only decreasing the series. So what does that give you? The original series, which is fn divided by n square, is greater than the sum of the terms where all the numerators are on their natural position, and you do that till capital N. Now, if you take the limit capital N tending to infinity, the right hand series diverges to infinity, which from the above inequality means that the series actually diverges. So what we have proved is that for any bijection, the series diverges. So there is no bijection for which this sum is finite, and hence the answer is B.